All right, welcome back. And let's see. Do you see where I am in the book? Section 5.6. And the author has this quirk in the book of dispersing problems in the text itself. So the website calls this 5.6.8. If you actually were to come to the end of the exercises in section 5.6, it starts with problem 9. That's because there are 8 of the problems exercises distributed through the book. So the author just kind of likes to do that. So anyhow, well, that's why it's where it is. This problem says, a canoe travels on a river whose current is running 2 miles per hour. After traveling 12 miles upstream, the canoe turns around and makes the 12-mile trip back downstream. The trip up and back takes 8 hours. What is the speed of the canoe in still water? So I don't know, that kind of sounds like the problem I did at the end of the previous video from chapter 3. But the similarities between this and even the coffee problem are so great, I just don't see a reason to wait. And so I like to, combine ideas when I can. So here's a summary of the problem. The river flows at 2 miles per hour. It's 12 miles upstream, 12 miles back, 8 hours total. And we have a 6-cell table waiting to be filled in. And I'm going to have to explain something before I do. There is still the idea of rate, time, distance. And you know what? Get used to the idea that some cells are harder to fill in than others. I mean, that's certainly true. Numbers, if a cell has a number, that's pretty easy, but sometimes the formulas get pretty advanced. All right, so I told you you're going to need to be familiar with this formula, distance equals rate times time, but it has 2 other formulas. Rate equals distance divided by time. If you think about it, if this is true, this has to be true. And then time equals distance divided by rate. How do I memorize all 3 of those formulas? With this little device here. I already kind of talked about this for a moment before, but if I cover up the D, that's the formula for distance. It's rate times time. What if I cover up the T? The formula for time is distance divided by rate. And what if I cover up the R? Formula for R is distance over time. That is going to be very important to us moving forward. All right, so what do I know? River flows at 12 miles per hour. It's not going to really help me. I guess I'm going to do fast and slow here. I say again, if you're just watching this video, make sure you watch my previous video on chapter 3. All right, so I do know the distance is 12 in both cases. 12 miles there, 12 miles back. 8 is the total, so the total time is 8. So that doesn't help me right here. I can't, I mean, it's not equal. It's not like 4 and 4. Total time is 8. I can't put any number in there. I'm going to have to wait on that one. But how about the rate? Well, once again, we're going to call the we already know the river speed. What we don't know is the boat's speed. So we're going to call the boat speed B. And what is the rate? Well, the rate is going to be the boat's speed, the fast rate, boat speed plus 2. And the slow, it's going to be the boat speed minus 2. And by the way, it's very important to understand the boat is going faster than the river, so make sure you subtract big minus small. In other words, it wouldn't be right to say 2 minus the boat speed. We're assuming the boat's going faster than the river. Otherwise, he wouldn't get anywhere. He did make it back. So we have that. All right. So here is why I have my little table over here. I needed the formula for time. The formula for time is distance over rate. So this is the distance, and this is the rate. And this one, the distance is 12, and the rate is b minus 2. It's a formula, and it's a fairly involved formula based on multiple things that we've talked about already. It's based on distance equals rate times time, because that's the formula that gave us this formula, that gave us this table. And it's based on the rate that we calculated earlier. In other words, there's no way to fill in these cells just right away. I think I mentioned that. Be careful when you ask a question about a very late step in the process. Don't ask the question, yeah, I understand everything, but how do you get this? I mean, if you don't understand how this came up, make sure you think about all the previous things I talked about before you question why you don't understand that step. In other words, maybe you missed the idea that time is equal to distance over rate, or that if I put a number in here, it's a distance. I mean, all of those things are important. All right, so I know I said on a previous video, the coffee problem, that we used all 6 cells. Not anymore. We don't use all 6 cells. We're just going to use 2 of these cells. I also say this. This is more like chapter 1 than chapter 3 because there's only one unknown. Remember, chapter 3 was 2 unknowns, but chapter 1, just one unknown. I said I'm going to use 2 cells. I didn't say which ones, but I haven't used that 8 yet, right? Total time. And so this is a fact that you just kind of have to think about. Time 1 plus time 2 equals the total time. So if I call this time 1, that time 2, I'm just going to take the contents of that cell. It's 12 over b plus 2 equals 12 over plus 12 over b minus 2 is equal to total time 8. So I just kind of drop those in. Hopefully you remember how to do this. This is a topic we previewed. How do you solve something like this? Well, you multiply by b plus 2 and b minus 2. In other words, we're going to multiply both sides by the same thing in order to create a cancellation. And the cancellation is both of the denominators. So if you visualize a b plus 2 times b minus 2 just kind of inserting itself here and canceling, and sort of here again and canceling, distributing here and canceling, I'm going to get this line right here. This 12, the b plus 2 is canceled. I should have written that. I mean, okay, it's not wrong, but I should have technically written this as a minus. I guess I could say 2 wrongs made a right. I guess I did make that. Yeah, when I distribute this, this becomes the b plus 2 cancels, so I really get b minus 2. And then this cancels with this, leaving a b plus 2. All right. Or you can just think the way I had it was just those switched around. All right, well, of course, this is going to be 8 times that. So distributing that out, 12b plus 24, 12b minus 24, and this difference of squares, I get something that I have to think about how to solve this. When you have a b squared in a problem, typically, there's going to be an exception coming pretty soon, but typically we want a 0 side. So that's why I brought the 24b to the other side, and a factored side. So this is what I call factored side, 0 side. And why do we want that? Because we can set each factor equal to 0. Each factor contained the variable we're solving for equal to 0. I didn't worry about the 8. It doesn't have the variable we're solving for. Remember, that's what we're trying to do. All right, so I get the boat speed is 4 miles per hour. I also factored it and got b plus 1 equals 0, but that would give me a negative number, and speeds aren't negative here. So the boat speed is 4 miles per hour. All right, so that was a preview of a topic because it felt like the author brought that topic up earlier in chapter 3, and that's certainly true. Let's talk about 7.2.99. So I don't know if I have a flag on that problem. Oh, here it is. Yeah. These all read about the same. In other words, when you look at these, they all seem about, I mean, on the surface, they seem pretty similar. Zine decides to canoe 4 miles upstream on a river to a waterfall and then canoe back. The total trip, excluding the time spent at the waterfall, takes 6 hours. So total time is 6 hours. So I think that we're going to have time 1 plus time 2 equals total time, but don't want to get ahead of myself. Zine knows she can canoe at an average speed of 5 miles per hour in still water. What is the speed of the current? All right, so I want to kind of summarize what's going on here. Summarize the question and what's happening. All right, so the question is 4 miles up, 4 miles back. Total time is 6 hours, and the boat goes 5 miles per hour. This has nothing to do with this particular problem, but I think it's interesting. What did the author do with us? In chapter 3, that says chap, boat, river. In chapter 3, we didn't know the speed of the boat and we didn't know the speed of the river. In chapter 5, we did know the speed of the river, but we didn't know the speed of the boat. And here we are in chapter 7, where we know the speed of the boat, but we don't know the speed of the river. In other words, look at what I've given here. The boat goes 5 miles per hour, but I don't know the speed of the river. In fact, it says find the speed of the current on the problem itself. All right, so you're never really at a loss for what you're looking for. The problem will tell you that, but I just think it's interesting. The author gave us essentially the more complicated version first, where we didn't know either one of them, and then saved these up for later. But that's how the book's laid out. All right, so I wrote this down here. The rate is always the boat plus and minus the river. And you got to remember that. It's always the boat, because the boat's the faster one, so you want to take the boat and subtract the river speed. In none of the word problems we have here, does the river go so fast that the boat's going backwards. So the boat's always the faster speed. All right, so here's my 6-cell table. I already wrote fast and slow. All right, so the rate, well, I have the formula here. It's a boat, which we don't know. I'm sorry, we do know. The boat goes 5 miles per hour. So it's 5 minus the river, or 5 plus the river for the fast, 5 minus the river for the slow. The distance is 4 in both cases. And do you remember it? The time is distance over rate. Distance over rate. So whatever's in the cell here. In other words, if they had said, I don't know, the distance back was 8, I would have put an 8 here. The distance over the rate. All right. Well, sure enough, time 1 plus time 2 equals total time. So just take what's in the cell. Looks like I switch these around again. Oh man, okay, well, that's fine. Which one you call time 1 and time 2 doesn't matter. I'm taking this one and putting it there, and this one and putting it there. Time 1 plus time 2 equals 6. Now you didn't get 6 from the table. I got 6 from the original problem that said total time was 6. I multiply by 5 minus r, 5 plus r to clear fractions, and think through it. You know, do it yourself, but this is what I get. And I work with it, and I do have to tell you what is interesting about this particular problem. We're a little different about this problem. Let's see. I think everything here should be fairly clear. We multiply these out. It's like a minus b times a plus b. That formula, you're right here. A minus b times a plus b. We know that equals a squared minus b squared. So 5 squared minus r squared. So I get, all right, once I get to this line right here, I have to start making some choices. I'm up to now, and I just kind of simplified. But once I get to this line right here, I will show you what I'm trying to do. I subtracted 150 from both sides, divided both sides by 6, because I wanted, this is the first time we've seen it, but I wanted what I call squared side, number side. Squared side equals number side is a wonderful thing. If you can get squared side equals number side, you can just take the square root of the other side. So there's no square root here, any r there. It's like you take the square root of both sides. R equals the square root of this fraction. I didn't even bother reducing that fraction because I knew there was calculator time. So I grabbed a calculator, or my phone actually, before I started filming this, and I got R is approximately 4.28 miles per hour. Of course, this fraction, this turns out to be a long decimal actually, but 4.28 miles per hour. I think in the book it said 4.3 because they rounded it to one decimal place. And that is something. Be very cautious about what you're rounding things to. You don't want to get a problem wrong or marked wrong by the computer because you gave more decimal places. Whatever it says. Some problems do say round to one decimal place. Some problems say round to 3. I mean, just make sure you keep that straight. I'm sure you've done enough of these already to know that. But that is why we summarize, why we kind of leap ahead on these in chapter 3. Really has to do with this right here. I could have waited and talked about these one at a time as they came up, but I just don't think the connection would be made. And I guess the good news is that is everything we do with a 6-cell table for the entire semester, where there's not like, I'm not going to say, oh wait, there's another 6-cell table. No, that's really it. We use 6-cell tables in chapter 3. We use them again in chapter 5. We use them again in chapter 7 for these types of word problems. I guess I should say in chapter 1. But I just wanted to get that whole topic, through that whole topic. So that is really my, preview of word problems that started in chapter 3. I still have another chapter 3 video to make, but again, I don't want to get these too long. So I'm going to stop this one, and there'll be another chapter 3 video, even though I didn't do a chapter 3 problem in this video. But there'll be another chapter 3 video coming up. All right. See you then.